In this video, I'll explain to you how to write the electron configuration for ions. So you consider it as exceptions because they don't follow the patterns of the ones for atoms, which are just pretty much the elements. So ions. So if you recall from previous videos, we have two types of ions: a cation and an anion. Whereas the cation is positive and the anion is negative. And another way to say something is positive is to say that it is electron deficient, and if something is negative, it is electron rich. So it will have more electrons than usual, or less electrons than usual for a cation. And what happens to this is that when you have a cation, you will have to take out electrons because it has to be like what you'll usually do is write your electron configuration for an atom, thinking that's an atom, and then you will modify it. So for a cation, you will subtract electrons depending on the charge. So if it's like Al3+, you'll have to take out 3 electrons. So it's going to be minus 3 electrons of the usual configuration. Or let's say it's chlorine as an ion. That's an anion. It's electron rich, so you'll have to add 1 electron. And it depends on the charge of the ion. You always have to look at the charge. That will tell you the number of electrons you have to add or subtract. And you subtract it or you add it to the valence shell. I'll talk more about valence shell, inner and outer electrons in the following video. But it's basically you have to subtract it or add it to the one with the highest energy. So let's do an example. So I'm going to do an example for a cation and an anion. I brought up aluminum, so 3+. So as I said, you want to write it as if it was an atom and then modify it. So let me get the periodic table. There you go. Aluminum is 13. So we're at 13 here. And let's do it as usual. This should be a pretty short one, so I will not write the abbreviation using a noble gas. So it'll be 1s2, 2s2, s2, 2s2, and it will finish in a 3p at 3p. So you can just jump there. So it's going to be 2s2, 2p6, 3s2. So I did this part and this part, and I'm just missing one electron, so it will be 3p1. So that's how you'd usually write it if it was an atom. Now let's do the ion form. The ion form will want to take out 3 electrons, so it's a cation, so it's going to be minus 3 electrons. And you will want to choose the ones with higher energy. And the one with the highest energy is 3p1 because as you go down in a subshell, so SPDF, F is the one with the highest energy. So this one will go out. We'll lose 1 electron. We still need to lose 2 more. Then the one with the second highest energy is 3s2 because this 3 means it's higher energy than this 2. So the P doesn't really make a difference. So these 2 electrons will go out. And then we'll have 1s2, 2s2, 2p6. And that's how you write the electron configuration of aluminum in its ionic form. So a good way to make sure you did it right is you use this third. So you use this this number. In this case, is the 13, so the atomic number. And if it's a cation, you will subtract that 3, so it should be 10. We have 2 plus 2, 4 plus 6, 10. So it's right. But you have to be careful with which electrons you take out. I mean, you could have taken out three electrons from here, but and if you did this, you could say it's right. But it will not be as stable as it wants to be. So now let's do an anion. So Cl minus, yeah, let's go with chlorine ion. And chlorine is 17, so we'll do the same as in aluminum. So you just it's going to be a 3p5, 1s2, 2s2, 2p6, 3s2, 3p5, and that adds up for 17, so it's right. And with practice, you will just like look at it and it will come out easier. So don't worry about that. Just practice a lot. That would be its atomic form if it's an atom. Now let's change it to its ionic form. So it's an anion. You want to add 1 electron. So our chloride ion will be 1s2, 2s2, 2p6, 3s2. All of those are full, so you can't add more electrons than a subshell can hold. And this is a 5. So if you, as you may remember, the p subshell can have a maximum of 6 electrons on it. So it can still hold 1 more, and that fits perfectly for chlorine, for the chloride ion. So it can be 3p6. And just to prove we're right, 17 is going to be a plus for an anion. So it's, just think of it as the inverse. If it's a minus, you just put a plus. And it's going to be 18. So 2, 4, 10, 12, 18. And usually adding an electron, it's easier because there's only one place you can add. It's not like taking out, you can take out anything. So you add it where there's something missing. Because you cannot add more than the max it can hold. You cannot have a 1s3. That is wrong in all levels. So well, that's it for the ions. And there's 2 more videos on electron configurations. I'll be talking about inner, outer, and valence electrons in the following one, and then I'll just make one for practice so you can see, so you can use all of this information. And well, as always, if you found this video helpful, make sure to like it and share it with your friends.